Hi everyone, we are Group 10. This video is about the agriculture industry in China. This is our team members. Next, this is the lineup of the video. Let's move on to the introduction. Agriculture, which spans thousands of years, is the art of raising plant life from the soil and rearing livestock for the use of mankind. Four major sectors in agriculture can be identified as livestock production, crop production, agriculture economics, and agriculture engineering. China, who began farming with the cultivation of wild millet before thousands of years ago, has risen up to the peak of agriculture industry in world with the aggressive development by the use of technology. Let's move on to the components of technology that has been transferred. Technology transfer can take place in main four components of technology as technoware, infoware, humanware, and orgware. Agriculture in China has mostly impacted by the technoware, which include machines, equipments, and softwares. We can identify these five technologies: agriculture drones, cloud farming, big data, sensor-embedded farmlands, and intelligent greenhouses as main transferred technologies. Chinese farmers use agriculture drones to increase crop production and monitor crop growth. They use fully automated pesticide spraying drones without human piloting. Chinese agriculture industry use cloud farming technology with the intention of providing farmers with timely and efficient solutions for both their small and large scale farming. They use a platform called Modern Agriculture Platform. Especially with the use of app of this platform, farmers can check real-time humidity, temperature conditions, pest and disease warning, and also the e-education, and the farmers can get consultations. Next, the big data, which has improved accuracy of decision making of farmers. With the use of big data, farmers has been able to get the use of the results of collected data and make more accurate decisions. Chinese farmers use sensors embedded on farmland to detect whether soil needs water and whether temperature is good for growth. And also, the Chinese farmers have moved to the concept of new intelligent greenhouses. With the integration and introduction of the foreign advanced technologies like advanced greenhouse technology, soilless cultivation technology, and industrial planting concept combined with the domestic production practices. This new type of intelligent greenhouses adopt the Venn structure of modern greenhouses, which help to utilize the space. This new type of intelligent greenhouses adopt the has ability to install various equipments. So by that, the various sensors in these new smart greenhouses can monitor temperature, light, soil, humidity, and carbon dioxide concentration, and then input this data to the intelligent control system of the greenhouse. By that, the system make analysis and control and generate reports which help in creating the optimal environment for plant production. As a result of the high development in the technoware in the agriculture sector of China, humanware also needed to be developed parallelly. Humanware included the skills, knowledge, and expertise, especially the computer literacy in order to use the platforms and apps, and understanding of the setting of automated machines such as drones are important. Moreover, the Chinese farmers should be aware of the big data mining and how to use the softwares and machines to make the use of big data. So that's it, and let's move on to the nature of the technology transfer. Kasuri.
Thank you, Nini. So let's move to the nature of technology transfer. When the goal of the agriculture technology transfer focus on in China by extending the science and the technology in rural areas to improve workers' quality, to direct farmers towards vigorous rural economic development through advancing science and technology to promote the growth of rural market economy. So When we talk about this new technology, traditional one to the new technology transfer, there is the agriculture drones, which is the mode of transfer is the vertical transfer, where they have used the research method for when transferring the this agriculture drones into the agriculture drones. And the category was regional transfer, because these agriculture drones are mainly invented in the China, then it was transferred into other areas. Then we have the cloud farming technology, which is also the vertical transfer, and the category was the international transfer, where they use the cloud computing and they transfer into the cloud farming. Then we have the IoT technology in farming. This is also done after the research. So the mode is the vertical transfer, and the category was cross industry transfer, because IoT is firstly used in the IT industry, then it was transferred into the farming industry using their new technologies. Then we have the modern greenhouse technology. It was a horizontal transfer, because this is in China, and it is used in the various flowers for the maintain the flowers and the various artificial, like the new flower farms. But after they have modernized this greenhouse technology through the embedded systems, new embedded systems and circuits, and they have created new like the uh, plants through the genetically, and improve the plants, the agriculture plants. So after this doing in the specific a region, this transfer to other regions in the China also. Then let's move into the technology transfer mechanism. We have the first agriculture drone. So it's founded by XAG company. So farmers had to staff heavy pressurized tank on the bank and the labor for hours to spray chemicals. So because of that, the company decided to specialize drone technology in the agriculture. So they intend to help increase the quality and the quantity of the crop produce, and they developed the cross dusting drones in 2013. Then so the competition also made for the drone side farms. And we have the IoT. So IoT based technologies and the sensors have been applied in many agriculture bases across China, and it can help test, alert, analyze and make adjustments to growing environment of plants. And the Australian agricultural company, the year focused on keeping farm condition to the certain condition. And then the AgroBrain solution also is based on the Microsoft Azure. And the benefits are the optimization of the inputs, treatments, and more efficient water usage. Then we have the cloud computing. So this is mainly doing after the research done by IBM, Yahoo, HP, Dell, and Microsoft, Oracle, and etc. And used in the telecommunication industry in the first by the China also. And it transferred into the agriculture sector. Then improve management level in weak field of the agriculture information construction. Then the achievers real-time visual monitoring of crop growth, and farmers have got the potential to quick get the surface information. Then also can automatically trigger corresponding improvement measures. Then we have the modern technology, greenhouse technology. So in the traditional greens are very common in the rural areas of China, but this has the disadvantage. First is the very poor heat preservation capacity, preserve resistance and capacity, and the temperature control management. Then we have the regular large amount of manpower and material resources in daily management. And also cannot meet the actual needs of modern agriculture industrialization. For this, with the increase international exchanges, the integration and introduction of foreign advanced greenhouse construction technology has fast content, a new intelligent greenhouse model has gradually formed. Then this new type of intelligent greenhouse generally adapted to the current parent structure of modern greenhouse in the world. Then this has the more advantages. So has the high land use rate, greatly reduce human labor, and suitable for mechanism operation and installation of various modern greenhouse equipment. And it can be made into high-tech vegetable demonstration gardens, plant factories, flower greenhouse, ecological sightseeing and greenhouse, etc. And has various sensors in new smart greenhouses, can measure the temperature in light soil and soil humidity, carbon dioxide concentration, etc. Then we have the market oriented and non-market oriented mechanism. So this has the direct foreign investment, which is done by the Kubota and the Desert Farm Missionary and the Japan Assure Beer Company. For these farming methods, they give the investment for the engage in the greenhouses and dairy farming. Then we have the joint ventures, which as a John Deere is a very renowned company, and the Jaimuzai Combined Harvest Factory in the China. And the March also they developed the Jaimuzai Program Missionary in the China. Then have combined this bridge between the Dutch technology and the Chinese horticulture industry. Then we have this technical collaboration, expert advice, job research ventures. For the technical collaboration, they have this equipment imported from the Switzerland, Germany, and the United States. So let's move to the non-market oriented mechanism. They are having 3 technical information services. So China also began to collaborate with the researchers in the wheat researchers, and they have the industry fair on the exhibition. We heard of many international nationally exhibitions where took place in the China. Then they have the participation in conference, seminars and workshops. They have this Chinese Academy of Agriculture Science, where they have hosted many events, conference in the China for the development of the agriculture. So I will invite for the window to have the conclusion.
The fusion of agriculture and technology matters, and China is doing its bit to lead the way. More recent breakthroughs such as agricultural drones, cloud farming, IoT technology, and modern greenhouse technology have significantly modernized the farming. These technologies have enhanced the efficiency and ensured the sustainability of the agricultural sector in the country in a robust phase. Thus, these technology transfers in agriculture play an essential role in boosting agricultural productivity as well as farmers' income, fostering agricultural restructuring and speeding up the construction of comparatively well-off villages. Hence, to conclude the above discussion, it clearly depicts how the transferred technologies have been adopted by China and how they have utilized them to accelerate the improvement in the agricultural sector. Now let's see what Sri Lanka can learn from this discussion. Digital transformation is extremely vital for Sri Lanka's agriculture, given its significant role in the economy as a contributor to GDP, income of the people, and employment. Yet, the sector faces a growing number of challenges and constraints such as low productivity, low product quality, and climate changes. Thus, it is very clear that Sri Lanka is lagging with the introduction of latest technologies in agriculture in relation to ongoing developments in the field. As a solution for this, moving towards high-tech agriculture can be identified as a positive step for the Sri Lanka's agricultural development. However, most farmers have limited knowledge of modern production methods and they do struggle to access commercial markets. According to our research, we recommend below steps for Sri Lankan agricultural sector. More R&D need to be carried out. Technologies need to be implemented at the field level. A different approach for smallholder farmers. Drone technology can help identify areas vulnerable to flooding, imaging, identify various factors, and to intelligent spraying systems. Central knowledge vault using cloud farming technology, big data analytics can assist in seed planting, analyzing, and sharing of weather forecasts. Greenhouse automation will help to monitor and control climate, water, and energy outputs. So that's the end of our discussion, and thank you for joining with us.